And the mic is working? Great. Yes, my name is Henrik Kramselund, or Kramse. That's my nickname in anywhere I go. GitHub, Twitter, anywhere. So I have this presentation, which is, by the way, open source. It's available as a PDF and a LaTeX source in my GitHub repository called Security Courses. You are welcome to steal anything from this slide and from all the other training materials that I put online. My main contribution today is not a tool or programming. I'm not a good programmer, but I know a lot about networks. So I have been performing structured DDoS testing for customers for quite some years now, and I would love to see you do the same in your networks. There's a little bit of contact information, and I will be here until Friday. So hit me up and talk about networks, infrastructure, IPv6. I'm really sad that we don't have IPv6 here, but we can probably do something about that. Create a fake access point or something like that. You're welcome to drop me emails. You're welcome to find me and ask me questions. Also, I have this disclaimer because testing networks can be a bit of a trouble, and doing stress testing of networks using DDoS is of course illegal in many countries, so you have to check up on your own country and where you're doing it, and especially beware that you're not doing a DDoS test on an IP that you do not own, because that would be a SYN flooding or some other attempt that could be seen as illegal activity, so you will get into trouble, and we have had people in Denmark being into trouble because of doing DDoS attacks and so on. So check your legal framework in your countries. So this presentation and these slides will have a lot of text. I'm sorry for that, but hopefully you will be listening to my voice, looking at the pictures, looking at the parts that I have put into bold text. So you're not supposed to read all of the slides, but hopefully when you get home, you will be able to read the slides and follow the instructions. So hopefully there's enough of details on the slides to enable you to perform DDoS testing after this talk. So you don't have to remember everything. The main part about this is that we are connecting to the internet. You have some kind of services that you put on the internet. You probably have some kind of value from that. Some of it may be monetary value. You want to keep some website up and running. You want to keep some sites up and running. So when we connect to the internet, we get this bad traffic. We are getting port scans. We're getting the internet tinnitus. It's a background noise all the time. And then sometimes people will start to do brute force attacks and all of the other attacks that we know of. And once in a while, you will also get the DDoS attacks. And we know that the actors that are performing DDoS, they are enabling DDoS attacks on even small customers. They can handle a flow of customers attacking smaller and smaller companies. So it's not just the big companies that are getting hit by DDoS attacks. We know that everybody's getting hit by DDoS attacks. So that's like why we are here today talking about DDoS. So in this talk, I will try to go through these 4 bullets, which is about firewall infrastructures. I think that a firewall is more than just the box that you buy. I will talk about doing port scans for discovery before we do the DDoS attacks. Then I will do some detailed advice about how to actually perform this DDoS attack. Using some of the existing tools that are available out on the internet, you can run them from a standard Linux machine, and it's not very hard to get started doing DDoS testing. Then I have some advice, and that's very opinionated, about how to protect your networks and make them more robust towards DDoS attacks, and that will also make them more reliable in many other ways. So hopefully you will take some of that advice and reuse them on your existing devices by configuring your devices better than they are by default, will make your network better. So hopefully you can increase the protection and robustness of your network, and I can say that is real because I have seen it in customer networks where we have perhaps improved our security stance towards DDoS attacks like 10 or 100 times in some of the scenarios. So really go and read the manual for some of the features, because the firewall vendors, the router vendors, all the devices, these vendors, they don't know how your network looks. They don't know your mix of traffic. So it's very important to look at your configuration and improve your configuration across what I call the firewall infrastructure. These attack tools that I will be talking about today is developed by others, and I'm very grateful that we have this open source penetration testing tools, attack tools, packet generators. So you can easily find them and implement them in your own infrastructure. So starting out, the internet is trouble. So we know that going onto the internet, connecting to the internet, having a business on the internet, we will get all of these attacks. And I have taken some of these numbers, which are quite annoying, quite big. These are from NetScout. They show that they have seen an increase, and we see an increase year after year of DDoS attacks. We are also seeing that these DDoS attacks are huge. So whenever I see a number like 612 gigabits per second, I definitely not have devices that can handle 600 gigabits of traffic. Luckily, my network is not getting attacked by 600 gigabits, and often we can contact our ISPs, and we can get services, and some people also provide DDoS protection like Cloudflare and others. So the biggest attacks we cannot handle ourselves, but we can actually go a long way in protecting our networks and make them more robust towards the smaller attacks. And also some of the smaller attacks are just a test to see how broken our networks are, if we are a good choice for doing further attacks and doing further ransoming and hijacking or doing other stuff on our networks. We also see the number in red, which is 453 million packets per second. I'm going to be using this PPS, the packets per second, as a rate of packets that are coming in over some kind of interface over a second, and that can be in the millions. If we're looking at a 10 gigabit connection, the maximum number of smallest packets you can send on a 10 gigabit is 14.8 million packets per second. And usually your interfaces will not have this number of packets because you will have normal traffic, you will have 15 bytes packets, 1500 byte packets, so you will be transferring actual data. But if we're talking about attacks, sometimes the number of packets per second can become a problem before the bandwidth is exhausted. So a 10 gigabit connection can be 10 gigabits of bytes, but it can maximum be 14.8 million packets per second. So these numbers are interesting when we talk about doing DDoS attacks. My advice is that we should not give up when we see these large numbers. We should try to focus on our networks, improve them as best as we can. I think that's one of the foremost options and objects for some of our security people like us. We must do as good as we can with the resources that we have. And sometimes you can do a lot with the resources that we have already. I also have these definitions of firewalls, and I have tried to highlight some of the things that I think are interesting in these definitions of firewalls, because going back to the first firewall book, Cheswick and Bellowin from 1994, they had this definition where they say a firewall is a collection of components. And I think that's really interesting, and that's how I view firewalls. I was in a little bit of a Twitter discussion yesterday because talking to a vendor, they say a firewall is this box. When I talk to an enterprise, a firewall is this network of devices, multiple components. And they must obey to some kind of local security policy. And I think that's very important. And for a lot of our security work, we have to do some designing and architecting, like the keynote said. And it's the same with networks. We have to look at what we provide, what we want to provide. Do we want to provide every protocol to the internet? No. We probably want to provide some web services with HTTP, port 80, port 443, but we do not want to provide IPsec to the whole internet. So maybe we should do some configuration and do some local security policy designing and implement it in our networks. Another definition is this one from definition of firewalls at Wikipedia, and I really love that this one talks about a network security system. So it's not just, again, a single device. It's actually supporting devices, multiple devices. It's a complete system where you monitor, and then you can control the incoming. But it's quite important to actually monitor and see what kind of traffic you normally have to be able to protect that traffic, so ensuring that that traffic is passed and other traffic is turned away. So I really love these definitions, and that's actually how I like to view firewalls. So in my opinion, it's not necessarily a single device or a single cluster. It's not a single component. It's multiple components. Looking at a firewall in the vendor's eyes, they will have these nice devices. They will test out these devices. They will optimize them. They will implement hardware, chips and hardware layers to ensure that they can transport packets quickly they will implement lots of features. They will come out with version 10, 11, 12, 13, 15. Every year they have to come up with new features, new marketing speak to be able to sell their new versions. And it's fair enough here, they have a commercial product, they want to have features. But sometimes commercial products are being oversold. And when you look at the actual devices that they have, they can use a testing generator, a traffic generator. They will buy some commercial ones that will do an iMix. What is an iMix? An iMix is some kind of mix of internet traffic that doesn't really match anything that we have in our networks, because your network will be different from my network. So they can test their devices, they can optimize their devices, they can list the highest numbers of how many bits, how many packets, how many screens, how many things they can implement. And that's all fine and nice, and then they delivered it with a default configuration, but the default configuration again will not suit your network. I have had customers where 100,000 concurrent sessions is normal, but I also have other customers where like 20,000 concurrent sessions would be just over the top, too much, too many concurrent sessions. So you have to tune your devices, and they have the documentation, but they also have really, shitty configurations listed online sometimes, especially in the VPN area. They are still listing configurations with triple DES and DES, which is like, oh no, we are not going to implement triple DES in VPN today. So beware that a firewall in the vendor's eyes is typically some kind of device they have optimized. And they say that this device can do everything. And I took this quote, so that's not my words, but it's like, can your firewall flex in the face of change? Like, what? What? I don't need a firewall that can flex. It's just, I want a device that can perform good. Looking at it into the enterprise mindset, I would consider it more like we have a firewall. People say we have a firewall, we may have a firewall administrator, a group of people that will configure the firewall. Then we have another group, which is the networking group. We have another group, which is the application developers. We may even have some people doing load balancing. And we should talk much more together in these groups. We should talk about creating some kind of coherent infrastructure that can protect our services. So sometimes after doing these DDoS testing, we have had meetings with 13 people from the ISP and all the way to the application developer, talking to all of these people all the way in the chain between our services on the internet and all the applications that we put on the internet. So a firewall should also be seen as more than these devices that we have bought that are protecting our internal networks on a magical way. When we say these vendors suggest that they can do everything in a box, they can of course do everything in software. And that's an important part, because some parts can be done in hardware, some parts needs to be done in software. And especially if we're getting to the less used features, they will be implemented in software where they may have been optimized for the common case of, say, TCP, port 80, port 443. So TLS, acceleration and stuff and all of these things may be implemented partly in hardware, but some things will be implemented in software. And guess what happens if you send a lot of packets toward parts that are running in software? They will break easily. So my view again is that your infrastructure is based on multiple components and devices, and I would appreciate if we could start configuring them better, like using some kind of defense in depth in the network space, in the firewall space. And for me, it's about where are the bottlenecks, because there will always be a bottleneck. You will never have a network that can handle these huge attacks. You will have networks that have a bottleneck somewhere, but we can increase the configuration robustness so we can handle higher loads. This is kind of a generic drawing, a sample network drawing showing some kind of internet connections at the top, some kind of routers, some kind of security services, what we traditionally would call a firewall device, a firewall component. We have some switches, we have some load balancers, we have all sorts of devices. And looking at each of these devices, the specs say they can handle SYN flooding. Nice, nice. How much can they handle? Can they handle it all while doing all the other things that are listed on the spec at the same time? Probably not. I will focus today on some of the lower layer attacks, but there are of course also higher layer attacks like slow lorries and web attacks, and we can do a lot of things in the HTTP space. We can find a big file on your website. We can request that file again and again and again, essentially filling up the bandwidth from the inside. That is also one of the ways we can do it. But I will focus mostly on the lower layers today. Also, the things that I say today, I'm trying to consider actions and configurations and advice that will not lose functionality for your services, that will not be an administrative nightmare afterwards, because if it's too complex afterwards, it will also not be used, and you will have to remove it again. So hopefully it will be practically good advice that you can actually use in your own networks, hopefully. Talking about availability, network flooding, DDoS, going a step down into what they really are. We all know about a SYN flood. Hopefully, it's something that have been used many, many years ago on large portals, being brought down by, was it a 15 or 14-year-old mafia boy doing SYN flooding for the first time on a large scale. And today, we still have SYN flooding because it's quite easy to perform, and it's the most basic, and it's very common, and we have TCP services on the internet. So yes, SYN flooding will definitely be there. We're also seeing a lot of ICMP and UDP flooding, and for all of these TCPs, ICMP and UDP, we're also seeing amplification attacks where you're sending some kind of request that creates a larger response, and with a spoofed source address, you can do an amplification as an attacker towards a site. So even if you do not have large bandwidth, you can use a lot of amplification sources. So we are seeing these basic ones a lot on the internet. Looking at DDoS from my perspective, because I'm a security person, I want to ensure that my customers' networks and the networks that I build have resistance against all of it. I also go into other special packets, other special protocols, and my advice is, of course, we should be able to test all of the protocols, or we should turn away some of the protocols, configure us out of having to handle some of these more exotic protocols that we're not really using anymore. And you know your own networks, so you know which protocols and packets to allow, but some of these protocols are not being used in your network, so turn them away at the front door. Generically speaking, all of these flooding attacks try to abuse some kind of resource. It can be memory space. When we talk about memory space, it can be in all of these different places, like in the kernel, in the TCP state table. It can be in the firewall state table, number of concurrent sessions, connections. It can be all of these parameters that sometimes you can increase, like I'm using OpenBSD PF, and I can easily set the concurrent number of sessions to 1 million instead, which is nice. But you need to configure it in some cases, and in some cases there is just a maximum that you can set. We also have more hardware-related limitations in what we're using, like the network cards have some kind of interrupt processing, the number of packets that they can handle. We have CPUs in our devices, which also have a limitation in what they can do with packets, with data. So a CPU processing a packet can be really hard, and I will show a drawing a little bit later today. Also bandwidth, of course, if we're filling up the bandwidth, it's over, it's game over. And usually I would consider having a 10 gigabit connection as the least, the lowest, number of bandwidth for some kind of server setup, because that will allow you a little bit of gap to at least take the smaller attacks. So if it's the neighbor's boy trying to do a bandwidth attack on you with a 2, 3, 5 gigabit attack, it won't hurt your 10 gigabit connection. But if we go over 10 gigabit attacks, of course, they can be filled up. Typically on the internet, they're also using spoofed sources, but usually when testing, I do not recommend to use spoofed sources. I would rather the exact source show up in the logs, so we can also train all the response on the backside of all of this. So doing this testing is actually not just for the network people, the firewall people, but it's also for the responding to attacks on the internet, because the same symptoms as received while doing this testing will show up if we meet a real attack on the internet. This is a drawing that I took from the traffic processing on SRX series devices from Juniper Networks. It's one of the firewalls that I know very well. And looking at this, this is what it actually does for every single packet that arrives at the firewall interface. So there's like 15 different boxes it can go through while being processed in the firewall. Even if some of this is handled in hardware, some of it is being handled in software, and some of it may be deferred to the CPU if it has some specific characteristics. And guess what? We can try to mimic that characteristics, so we make more things go to the software, and that will hurt the firewall even more. So the less we can put into the firewall device, the better. Going into some real networks, or the networks that you may have, it all boils down to you have some kind of internet connection, you will have some kind of routing device. This routing device may be a provider routing device, or it may be your own routing device. No matter what kind of device it is, it usually will have some kind of control plane, which is where you do the configuration, and then it will have a data plane, a forwarding plane, where it will process all these packets that are coming through the router. These devices are actually very, very nice. They're built on FPGAs and chips that they have designed, and switching chips, routing chips, and so on. And they can handle wire speed. So they can handle a 10 gigabit connection, they can handle a 100 gigabit connection. Soon they will be able to handle a 400 gigabit connection, 800 gigabit connection. So it will be very nice to have like a 600 gigabit connection, and then getting 600 gigabits to your firewall. Good luck with that. Good luck with getting a price quotation for a 600 gigabit connection firewall. So the firewall on the back side of that routing device will typically also today have a control plane, data plane. Again, can do some things in hardware and some things in software. When we're looking at these networks, we want to find what I call pressure points, and we want to find a scope for doing this testing. And usually you will have some kind of link net which links the devices together, and then you will have some kind of announced network, which I call the hosting network here. So for IPv4 and IPv6, you will have a link net, which is typically very small, and then you will have a larger network, some kind of space that you have bought or allocated earlier. I have 1,000 addresses for my small company, and I have a small /29 link net. And for this DDoS testing, it's actually quite interesting to also look at the link net, looking at the devices in front, because some of the providers, at least in Denmark, they're not very good at configuring these devices securely. So they may have ports open on these control planes. They may have protocols open like BGP, the routing protocol open on this device. So you will be able to attack the router in front of the network. And what happens to the service on the network if you hit the router in front and it goes down, it reboots, it breaks the BGP tunnel connection, then the network is unreachable. So typically, I will attack all of these IP addresses listed on this. That would be the scope of the test. Then I would use something like Nmap. Nmap is a great tool. You probably know it, all of you. I would port scan the whole link net for IPv4. I would ask about the IPv6 ranges because IPv6 space is so large. So I would ask which networks are in use, which IP addresses are in use. That would lead back to a number of IP addresses that are active on this network. You will have some services that you care about. You will have some development services or testing services that you do not care much about. But some of these services can be used for checking, service checking that the network is up. So you can use some of these services that you have found to verify if the connection is up, if the network is running, is the firewall running. And then you can have some specific checks on the HTTP being attacked or whatever service you're running that is important for you. So I will try to create a list of the ports and the protocols that I can attack, and which ones should keep on responding even if some service is down. So if the application goes down and does not respond, I can still check if the router and the firewall is still running and if there's any latency changes. So putting on some kind of monitoring on these is the next step in the DDoS testing. And typically I would advise that you do the testing at night. We start typically the testing at 2200 and then run all through the night until 5 or 6 in the morning. That will give you a nice window, like 8 hours, where you can do the testing and not hurt production a lot. If you have a service that needs to run during the night, like Netflix, it may be a bad time, but find a time that is suitable for breakage, because there will be breakage. I usually set up this testing a week before, so I get these nice green graphs. This is a tool called SmokePing, which is very nice for showing both the number of probes that are lost. In this case, there are no lost probes, so it's green, 0 lost probes. It also shows with the graph, with the bar, if there's latency changes in a lot of these probes. So it's sending 20 probes every 5 minutes by default, but usually for DDoS testing, I would turn it down to checking every minute, so I quickly can see if something's changed. I also use an external service, and that's very nice to have a third party verifying if a service is down. So it's not just my testing tools from where I do the test. It's not just my testing tools from my home, where I typically sit during night to do this testing. It's also a third party, which, like Pingdom, can check from multiple countries, multiple places on the internet. So it's a very nice verification having this DDoS test. This one is checking an HTTP and showing that it is green running up to the test. So if it's an unstable service, it doesn't really make sense to check it, because then you cannot really see if it's unstable and therefore it's unavailable, or if it's the testing that makes it unavailable. So these are the ones that I use, and I'm not really recommending Pingdom. You can use whatever you like, and that also goes for any other product names that I listed, like the Juniper SRXs. You have to evaluate by yourself if you want to use those products. So we have now used Nmap. We have not used Nmap yet, because I will show some of the commands, but we will use Nmap. We will use some specific options that are not very advanced. That will give us a list of endpoints, ports, protocols. Some of them we will use for attacking. Some of them we will use for verification if the network is up. Some of them will show if the application goes down when we do the testing. So the 1, 2, 3 on this slide is that we want to use Nmap, port scan the network, set up monitoring, not shown, and then run tools that are called hping3 and T50. These two packet generators are some that I have used for, I guess, more than 10 years. I'm really happy about these. I'm really happy that they are open source. They are very, well suited for this testing, because the hping3 can actually allow us to turn up and down the speed of the testing, which will become important very quickly. You should expect things to break. Something will break. I have a bit of findings at the end. Some things that have been surprising when you do the test, because you are expecting the firewall and the router and the application to go down. But sometimes you have some consequences saying if the firewall goes down, then the database connection from the web application through the same firewall goes down. And we also measure if the applications and the network returns back to normal. And in this case, with this customer, with a database connection over the firewall, the database connection had to be initiated manually again. So for every test that failed, made the firewall overloaded, they had to manually re-enable that database connection. Now that's really bad if it happens at 3 in the night or during the middle of the day and people are not aware that it's down, how to get it up and running again, how to initiate that database connection over the same firewall. So a lot of consequences when we do this testing. I have some hints throughout the slideshow, so they're marked with hint: save the scope in variables. So instead of having to type an IP address at 3 in the morning and mistyping an IP address, that's bad if you just start DDoSing the NSA, or in my country, the police, or some military installation. So my hint is to export the customer net 4 into some variable, the customer net 6 into some variable. Then you can use these variables in all sorts of scripting, all sorts of copy-paste commands. You can repeat the commands. You can be sure that you are not attacking the wrong target. So carefully enter the IP address into a variable, and that will be used for the rest of the presentation. I said to use Nmap, and I said to do a full scan of the linked net. So this is just the Nmap commands for doing a full TCP scan on IPv4 on the customer network. And in my case, it just shows port 80 and 443, very common ports. So these will be the ones that we will typically attack. We will also attack others. We will also send other protocols, but they may be the main targets that you care about. And likewise, you would do the same on IPv6. maybe I forgot to actually add the -6. I don't remember if Nmap, I think Nmap needs a -6 for the IPv6. Sorry for that. I should have tested the command, but it can do IPv6 scanning, and I think IPv6 is getting more and more interesting. We are using IPv6 in lots of places. We can see the statistics going up, and also a lot of the firewalls are not very well suited for IPv6. So they're not optimized for that, because that's not the common case that people are running IPv6 in our part of the world. And I also know that ENW and Troopers love IPv6, and I love IPv6. I did my thesis about IPv6 in 2002, so 20 years ago I handed in my thesis about IPv6 this summer. This is just a documentation for these options that I have used. Not very interesting. They save the output in XML format, which can be converted into HTML. Converting it into HTML will make it very easy to just copy it into your documentation for this. So when you do a follow-up on all of this, you have some nice output to show. We had these ports open on the ISP router. Can you please turn off these ports so we are less vulnerable on the ISP router? And on our services, we found that these and these ports are open. Also, a small talking about these routers in front of the network. This is actually real live data that came from a test. So while doing these port scanning, doing some UDP scanning for SNMP, the Simple Network Management Protocol, we saw that this router, which is a Cisco device in front of a customer network, it had an uptime of 732 days. And I have also seen +1,000. I think I've also seen 1,800, and we talked about it one of the days. And it's just, why would you have a machine, a device running for so long? Because if it has an uptime of 732 days, it is definitely missing some critical vulnerabilities, critical firmware updates. And since we can see it's a Cisco device, we can quickly find out with the MAC address approximately when it was created. We may even be able to find the model or approximate model. So we will be able to target it more if we know more about it. And this is really bad. So in some cases, you go back to the ISPs and tell them to sharpen up a bit. Then we get to the actual doing the DDoS testing, and I have some prioritized list of the things that you should test. This is just a very, very initial test of doing DDoS structure testing, but these are the most interesting because these are the ones that are getting amplified on the internet. These are the ones that you have to handle because you have services running TCP, and if you have services running TCP, you must allow some SYN packets to come into your network. I will use this I usually use this HPing3 packet generator because it has this option of doing an interval, so you can turn up and down the speed of this, which will be nice. So we can start with 100,000 packets per second, 200,000 packets per second, 500,000 packets per second, and then suddenly the people in the other end, where you're communicating using some kind of talk protocol, IRC, whatever you want to use, but tell them that now we are sending 500,000 packets per second, and they can say, oh, the CPU on the firewall is 33%. So if I increase the attack, it may go up and go above what the CPU on the firewall can handle. So it's very nice to use this with different speeds to find out where the bottlenecks are, which devices are being hurt by this. And then, of course, you keep on turning it up, and you end up with sending packets in the millions of packets per second. So that's very nice. And this generator is also very flexible. It's fantastic because it can produce all sorts of combinations of source port, destination port, sometimes just changing the source port into port 80 or port 53 for DNS will go past some of the firewalls that we have seen. So you can just tailor packets and send them off using this HPing3. We also have this T50, which is also a favorite of mine because it has this special option, which is the one called Protocol T50. So Protocol T50, you don't know a Protocol T50, but that's just a keyword they have decided to implement in this tool, so it will send all protocols sequentially. Oh my God. If you're a firewall that have optimized a case and some hardware for TCP, UDP, ICMP, but then you're getting all of these other protocols, you're getting random shit crap that you must handle in your firewall. And if you're sending this like 1 million packets per second, it's really bad for most firewalls. So this is one of the commands that I definitely advise you to try out. It's available on Kali. It's easy to run. Some of these tools, they may not be the fastest because they are pretty slow, they are pretty old, but they can still get a lot of results. And typically, since we have like 8 cores, 10 cores in a generic PC server today, which I'm using for these testing, then we can actually send millions of packets per second. And that's good enough to make something break on the network. So the process now, after having found some targets, found some tools, is that you would want to monitor, attack, break, repeat. So that's basically an iterative process where you go through all of the test cases, the scenarios that you want to test, and you turn it up until it breaks. And if you turn it up to millions of packets and nothing happens on the whole network, good for you. That's an okay, that's a check. So that scenario is fine. But then you probably will meet like 3, 5, or more scenarios that give you trouble. And then afterwards, you should, of course, evaluate how can we combat this scenario. We can change this in the firewall. We can change this in our network. But make sure that you run through all the scenarios and then perform a change, and then you can run all the scenarios again. Because sometimes you will have to do a balanced configuration where you cannot use all of the features in your firewall devices and routers and switching and so on. So it's much better to just run all the scenarios, and then afterwards you can do the changes and then do a retest on another day, another night. I recommend having a common chat with network operators, customers, outsourced partners, the firewall administrator, or also if they are outsourced. Make sure that you bring some people together because they will notice things that you cannot see from the outside. So they will notice some logs on the inside. They will be able to give more information about what works and how bad it is for the network. And also the last bullet is quite important. I should probably put that in bold because any information resulting from this testing is good information. So any change in latency, any change in packet drops, any change in probe lost, response times, anything is good information. So getting to the attack part with the HPing3, exporting the custom IP into a variable, using a command like I recommend here, using the date, semicolon, time, and then the HPing3 command. And they are quite important because typically I would just do a complete script and then have an ASCII log of all my commands that I ran through the night. So I will have time stamped when I did this command. I will have seen with the time command how long did I run this attack for. And that's very important because afterwards you want to correlate your attacks with the logs on the other side, on the application, on the firewall, on the routers and so on. So please do a date and a time command. Then running the attack tool HPing3. In this case, it's just sending, was that 1 million packets with the C with minus I U60. So it will not be the fastest attack, but it will just send a small burst to show how it's working. And if that works fine, you can see on your own device that you're sending packets. You can see at the receiving end they are receiving your packets. Everything is good. You can continue turning up the attack. Removing the count, so it will just continuously be running this HPing3, and that will actually start to create results. Some of my recommendation during this test is that you run these tests for at least 5 minutes, even up to 15 minutes. Some of these attacks require some kind of build-up. So when I'm sending a SYN packet, it will get received as a session being established. So that will take like one line in the table on the devices, but it may take a little bit of time before we reach the millions of sessions that are allowed in these devices. So keep on turning up the speed of the attacks and also make sure that you run them for at least 5 minutes. 15 minutes is probably good. If you're sending something like 1 million packets per second over 15 minutes, that's quite a lot of sessions that get established. And then you will see on your firewall device, on your load balancers, on your routers and so on, some of these numbers will go high. And I know for a fact that some of the SRX Juniper firewalls that I have been using, they have had an 1800 second timeout for UDP packets. So that's really a long time for a UDP session to be kept in some kind of table. So run these attacks for some time. And take note of any change in response, high latency, lost probes. If something starts to be unresponsive, I usually use something like a curl on the command line to check an HTTP service. I will go back to my smoke ping and the graphs. And then if something goes wrong, I will stop the attack. We will note how long it takes for the service to return to normal, and then we will retest. So if something does not break, we'll continue to the next scenario, but if something breaks, we will retest using the same parameters. Sometimes we'll turn it down a bit to see if it was around that time or that size of the attack it breaks. We want to know the approximate level where it breaks and what breaks. Keep a log handy, write notes, start a session. I usually use the script command. I'm running all of this on Linux, by the way. I didn't say that, sorry. But I'm using a generic Kali Linux to run all of these tools. You can also run it on Debian or some other Linux, but my preferred platform for this is the Kali Linux. Also, once in a while, you can use the command psauxw grep for hping3, because I recommend that you run multiple processes, you run them in the background, and sometimes I'm running like 10 processes of hping3, and when you just want to turn down the attack, you want to kill all of these processes. So make sure that when you shut off the attack, you have actually shut off the attack. Running multiple instances of the tools, one process may generate 800,000 packets per second, and then adding some processes. You cannot, of course, add 100 processes, but you can probably add the number of processes corresponding to the number of cores you have in the CPU on your sending machine. So something around 800,000 packets per second, and that's actually an old number. Some of the older CPUs I've been using this on, I think it was something like an E5-2603 V3, like an old CPU. Then, apart from these basic attacks, I would also recommend some of the more exotic attacks, and you will typically get a lot of fun results when you start to spoof packets, when you start to send small fragments, bad checksum. Some of these devices on the way to the application will also notice if something is bad, and if something is bad, they will log it. So they will send a log message. So sending a log message can also be quite expensive. It can be quite expensive for the device that is sending the log message, has to generate some text, send it over syslog, because that's what we all use still, and then it needs to send perhaps 800,000 log messages per second. That's like, oh, no. Oh, no, so not per second, but it was 800,000 log messages in minutes. So that's really, really a hard task, and it's a hard task for the logging system to ingest all of these messages. So in many cases, we also see that the monitoring go blind while we do these attacks. The actual commands that I usually use is the one like SYN flooding, SYN-ACK flooding, ICMP flooding, UDP flooding. Again, I will use the hping3 tool because it's very flexible. You can start to play with all of these parameters when you get later into the test, but these are the basic ones that you should try out. And when you have tried these out, you can definitely find good options in your firewall devices, components to ensure that you are not as vulnerable to these attacks, and then you can of course move on to the more specialized attacks. While I'm doing this, I'm sending all of these attack packets. I will typically use the IFPPS tool from the NetSniff package that will show how many packets I'm sending per second, which is very nice. And it's very nice if the network people at the other end can verify that they are receiving these packets. And typically I would inform some of the ISPs on the road from my network to the customer network. I actually do this across the internet, but typically I do it in Denmark, from my network in Denmark to another customer in Denmark, but I have also done it in some cases internationally. But try to find a way where it's allowed to do this attack so you're not getting shut down during the attack. Some further hints: speed, we already talked about that, adding more processes, using this flooding with caution because it just runs max speed and something will break and you don't know what broke first, what is wrong in the network. Doing a TCP testing with some kind of port that is allowed through the network. Often that would be port 80 and 443, but depending on your network, you can probably find other interesting TCP services. Focus on attacks that are hard to block, like the TCP SYN that must be allowed in. But in other cases, if it's a pure hosting network, never creating outside traffic, they will never receive the response packets, and they will never need to send a SYN packet out, perhaps, from that part of the network. So some of the attacks we can actually block quite easy, like like a reset attack, RST, the reset attack, can probably be blocked in a lot of networks without losing any functionality. Time is running, sorry. Focus also on the routers in front. Don't forget those. If I find that the router in front is not protected with this, what we call a router protection filter, it has SSH open to the device, you may be able to just create an attack using port 22 on the router. You can start to do a lot of requests on port 22. That's not very nice for a router in front to be overloaded by SSH, but then, of course, the ISPs should have blocked that port. It should only be available from the management network of the ISP. Or if it's the customer, it should only be available from the customer's management network. And protocols like BGP, which is vital for keeping networks up and running, if that port is open, that can also be attacked. And some of these attacks will actually hurt the what is called, control plane. So that will hurt the control plane, and that will make the router unresponsive, so it may be able to perform some of the tasks, but if the BGP breaks, it will inform the forwarding plane not to forward packets, and that will break the network connectivity. A small note about IPv6 testing, because I included it in the title, and I'm very fond of IPv6. A lot of the favorite tools that I have used have not supported IPv6, which is a shame. So the options that we have is, of course, to find another tool, modify the tools, use a newer tool. These tools that I'm using are open source, and I really love the HPing tool. So back in 2018, I just did a search and replace for INET to INET 6 in the code, more or less. 20 years ago, I did it with a port scanner, but in this case, it was just the HPing tool, and that made it possible for me to send IPv6 packets. So it is possible to use older tools, update them. I'm not a great programmer, but I can do search and replace, and then I can do make until it compiles. So I was able to do IPv6 SYN packets using HPing 3, and this is on a GitHub repository, and I verified yesterday that I can actually still compile this on Debian, so it still actually works and can send IPv6 packets. But moving on to another tool, which is a great tool, which is more recent. I believe it was created around 2015, called MoonGen. It has evolved into a library that you can use from other programs, and that tool actually supports IPv6. So I'm just going to skip some of these and then go to this slide, which is about this MoonGen tool, because as I said, HPing is not the fastest tool, but using this MoonGen tool, it will actually allow you to use DPDK, which is Data Plane Development Kit, originally from Intel. It's now open source, which I'm very happy that it became open source. It also allows other network cards than Intel network cards. It's a very low-level kit. This low-level kit is quite hard to get started using, but using this new tool called MoonGen, you can just take a generic PC. This is a small Dell Precision 3240, not a recommendation, it's just a device that I bought. It was cheap. It has an X5 PCI slot, so I could add a dual 10 gig Intel card into this very small machine, and then I could install a generic Linux. I have used Debian Linux. Then I have downloaded the tool MoonGen. This tool allows you to build support for DPDK in their tool, and then you can use it with Lua scripts. So basically, by using a generic PC, dual 10 gig card, Intel network card, you can buy them on eBay, you can do full wire speed 14.8 million packets per second attacks using Lua. So that's quite nice, and that actually is the maximum for a 10 gigabit connection, and it only actually uses one core. So that's really, really nasty, but also very nice for you, because you don't need much of a budget to be able to perform these testing. You can also, using this tool, maybe I should have, this one is in bold at the top, So it's just one of the examples. You can modify some of these examples. I have modified these examples. It's just Lua. And this layer 3 TCP SYN flooding Lua script could actually be printed on an A4 page. And it also has some options and help. So the main part of this is very little Lua scripting. And you can turn down the rate. So this tool will allow you, in this case, to send 5 gigabits instead of the full 10 gigabits. So it can be turned up and down like the HPing3, but it's not as flexible on the command line as HPing, so I still use HPing3 a lot. I skipped a couple of slides because I put them in the wrong order, sorry. If you want to spoof source and destination, you can of course do that. Spoofing the destination would make it go to the wrong place, but spoofing the source is quite interesting because as you dig deeper into how the network reacts, you can send the same IP as you're attacking, so that shouldn't be allowed into the network, and that is actually something the network people should fix. But you can also try to spoof another IP in the same network, so you're sending, for instance, a ping packet or a TCP SYN, and then the response goes back to not me, but to the spoofed IP, which is inside the network. So you get 2 for 1, sending 1 packet, but it results to 2 packets within the network that you are attacking. So some of these things are really nice to play with. Also, this HPing3 tool has some very nice features, such as the one with the fragments. So I have tried to highlight the important part, which is HPing3 creates a virtual maximum transmission unit, MTU, of 16 bytes. So instead of sending like full packets, small but full packets, it will send small fragments. And lots of small fragments will have to get stored on an intermediate device that needs to combine these fragments before they can make a decision to pass the packet or not. So this will again use up some of the resources on the devices in between you and the application. So it's a very nice feature and it's very easy to run. So it's a test case that I'd really love to perform. And it actually happens a lot. It works a lot in lots of places. If we start to do this testing, this is what the resulting graph will look like from the outside. You will see that probes are getting lost, latency increases, it will get worse and worse as you proceed throughout the night, and this is what to expect if you try to do this on a network that has not done this before. So even if you hope that you have configured your devices in a good way, you have hoped that the vendors have a good default configuration, this is actually what I see when I do this testing, which is why I highly recommend that you spend a night doing this. And like a whole project of doing this is very few hours, around 20, 30 hours in total, doing meetings, preparations, setting up monitoring. So less than 30 hours of work, some of it during the night, unfortunately, but still it's very good results and it exercises a large part of your organization too. So this was when spoofing started to work. So it gets red and purple and latency increases, and a lot of times these services get unreachable or the whole network becomes unreachable. I sometimes get the question if this is comparable to a real DDoS, and I think it is comparable to a real DDoS. We are using the test cases individually, and an attacker would of course be able to mix and match and use multiple scenarios at the same time. And of course you can do the same. So you can do HPing3 and you can run T50 and you can run MoonGen at the same time. And then of course it will be a mix of traffic that will probably break even more of your infrastructure. But still it will be harder to know which of these attacks were the source of the bad things happening. Getting to the protection, and I can see the time is not completely running out yet, but it's getting closer to this. This is my advice for configuring your firewall. So it should say configure your firewall infrastructure. Because if we have routers, we have switches, we have security services, we have load balancers. They are all optimized for specific cases. So a router can route, great, but it can also filter statelessly on the traffic coming in. So if you know that one part of your network is only using TCP, another part is only using UDP, then inform your routing people, make them create a stateless filter, so that will look on the individual packets. If it does not match TCP, it's not allowed into this part. If it does not match UDP, it's not allowed into this part. It sounds very simple, but actually it has a lot of benefit for the rest of the devices afterwards. So handle it as early as possible and make sure that you get enough bandwidth, you do stateless filtering. We also have something called real-time black holing and null routing, making sure that if you have a full table, if you have a full BGP table on IPv4 or IPv6, you can actually see a packet coming in, which is with a spoofed source address. But if that spoofed source address is not active on the internet, there's no way in hell you're ever going to be able to respond to that IP. So better turn it away before it reaches your application that tries to send it back to your router, which will just throw it away. So having a full routing table, making sure that you only respond to networks that are active on the internet, actually will turn away some of the noise in these attacks. We also have what we call shaping and fair distribution. We have class of service, quality of service. All of these features are implemented in our routers and switches. So we can say that instead of having 10 gigabits of ICMP traffic, why would I have 10 gigabits of ICMP traffic? Let's just have 100 megabits of ICMP traffic. And that can actually happen in these devices without any further cost other than a little bit of configuration, and you will not lose a lot of functionality by restricting ICMP to 100 megabits. All of these things combined will enable you to turn away packets that are part of attacks, turn away some of these scenarios. You can verify with these scenarios, we can verify with these tools that you are turning away packets. So this is what I recommend that you do. And this presentation has some slides about how you could design this protection. If you're looking at your network, it may be that in some cases you want full bandwidth, 10 gigabits, but some parts of the network only uses less than 1 gigabits of UDP traffic, so that profile can be put on your routers. Likewise, you can probably look at your network, you could do an address plan. In this case, I have tried to fit a small address plan on a slide. So for this 192.0.2.0/25 has TCP, and it only has these 5 ports. So if there's a packet coming in with another port, TCP, destined for this network, just turn it away. You don't want to have it further into your network. You don't want to have it hit your firewall. And that leaves up and frees up resources on the firewall so it can handle more of the real traffic which you want to have running even if you're under attack. So that's an important part, that you want to have real traffic, normal traffic, reaching your services while under attack. You can implement this, and there's a couple of slides showing how easy it is on Juniper devices, which I use. So Juniper devices allow you to do this edge blocker where you, from some sources, some networks, even some AS numbers, you would just throw away the packets. You can do a limitation of the protocol like ICMP 100 megabit, UDP 1 gigabit. That's nice. That's built into the devices. You can do this strict filtering, so what I just said with the destination address /25, you can say destination port and these 5. Nothing else gets passed by this router for this destination. Everything gets thrown away, and that is actually very, very nice. This URPF is the real-time black holing and the BGP parts, so making sure that only active networks on the internet are sending traffic, and you should all make sure that you're also only sending traffic from your IP addresses. So make sure that attackers cannot spoof from your networks. We are all in this together. Make sure that people cannot spoof from your networks. If you implement this, I promise that it will not solve all of your problems. I cannot promise that, but I will promise that it can reduce your problems. And in this case, I have an old example where we had some attacks, which are the spikes shown here, which combined is about 3.5 gigabit. And this was actually hitting one of our customers with a 1 gigabit firewall. But because we had implemented this, instead of sending 3.4 gigabits to the customer, we were actually sending less than 400 megabits. So the customer network, all the services were running normally. They were having a 1 gigabit firewall that could handle this load, so everybody was happy, except the people attacking. This would probably scale up quite a lot. I'm not sure if it would scale up to like 100 gigabit, 200 gigabit, 400 gigabit, because 10% of 400 gigabits is still 40 gigabits, so that's still a lot for a firewall to handle, but it will help your network. And sorry for getting very, very close to the ending. Just some interesting findings that we have seen. These ISPs with routers with 1,808 days uptime. We have seen big companies in Denmark are still using 1 gigabit connections. You should move to 10 gigabit. Usually we see fail at least 3 scenarios, and you can do a lot. We have seen a lot of outsourced, managed services becoming unreachable. We have seen logging systems fall over. We have seen the customer's own employees connected via VPN through the same firewall setup, losing connectivity, of course. So they became blind and could not control the environment, which is also very important if they ever get attacked by a DDoS. Instead of going to their home setup, they will take their car and drive into work to be able to manage the network. So my conclusion is that hopefully you should try this testing, investigate your existing devices. You can do a lot with these without having to buy new licenses. It's only a small part, of course, of your security. It's kind of like a fire drill for your organization, and it's quite fun to do. It's quite fun to do. Do we have time for a single question or no? If you have any questions, you are also welcome to find me in the hallways. We should not go over time. And as said, the presentation is on GitHub, Kramse, in the repository called Security Courses, and it's the latest commit because I fixed some typos today, so you can easily find it.